Users of spreadsheets, scientific notebooks, and similar environments often use custom tools and extensions. We believe that ad hoc tool creation is a natural part of creative workflows. Therefore, tool creation mechanisms should be both highly expressive and tightly integrated. Very few environments offer both these properties simultaneously. Smalltalk and Boxer come close. We'll show how we approach these goals in our hierarchical spreadsheet prototype. First, we'll briefly show our prototype. Then, we'll demo how the user can organically build some tools without the need to leave the system. Let's calculate the sum of the first 100 whole numbers. There's a nice formula for that. Formulas are expressed using nested cells with Lisp-like semantics. Syntax errors are not supported. Constructing expressions is still clumsy, but we are working on that. Creating links to other cells is easy. It is also easy to spot the target cell of a link. The result is displayed as soon as the expression is valid. All links are based on UUIDs. Cell names are documentation. Renaming cells never breaks anything. We can also define functions and use them in formulas. To express the summation formula as a function, we copy the formula into the function body and redirect the links to the function's formal parameters. Calling a user-defined function is as easy as creating a link to its definition. Functions can be passed as arguments to other functions. Let's now build a tool that helps us debug a confusing formula. We'll debug the confusing expression by evaluating its sub-expressions. We set up a link to the sub-expression of interest and evaluate it. Aha, the link just evaluates to itself. We have to wrap the link in a dereference. This is nice, but manually updating the link is tiresome. Let's try to use the current cursor position instead of the link. The cursor position is determined by a certain cell contained in the editor states cell. The content of the cursor cell changes as we move the cursor. This is the cell that interests us. Apparently, the cursor target cell ID is not stored as a string, but as a key in a single element record. Weird, but we can cope. We can use the key function to get the key in a single element record. We call key with a link to the cursor cell as argument. We don't have to dereference the link using the dereference operator because key does that implicitly if the argument is a link. Great! We can now use the current cursor position as the input to our sub-expression debugger. It works! 10 plus 2 is not 102, but 12 Perhaps it was the tight layout that confused us. The cursor target ID getter is useful, so we move it into a function, give it a name, and move it to our utils. An always-on cursor-sensitive tool would be annoying, so we equip our tool with an on-off button. The user-defined if construct quotes some of its arguments, so it is actually closer to a macro than a function. We just make things nice and tidy. Content visibility can be toggled with a keyboard shortcut. Sometimes manually toggling visibility is tedious. To remedy that, we create a tool that peeks into the cell positioned under the cursor. Ideally, the output of the peek tool should be an editable view of the cell being peeked into. We use the fact that any link can serve as a view to its target. All we have to do is generate a link from the cursor target ID and then switch the link to the editable view mode. Finally, we tidy up a bit and test that we can indeed change the content through the view. The last tool we construct will show us the relative magnitude of a number in a list of numbers. We start by defining and testing a function that performs the calculation proper. We again use our user-defined cursor target ID function to add sensitivity to cursor position. I forgot to call the function, but that's easily fixed. We see the tool works as expected. That was it. Thanks for watching.